So if it's the data engineering today, I would do three things completely differently. And honestly, doing them earlier would have saved me 6 months of running around in circles. When I was starting out, I did what most people normally do. I googled how to become a data engineer and I got list of about 10 tools that I needed to learn. Python, SQL, Airflow, Kafka, dbt, cloud, data lakes, data warehouse, and so on. So I started picking things randomly off that list. And the problem with that approach is not that the tools are wrong. I mean, all of them are actually being used in data engineering. The problem is that learning a tool without a picture of how they fit together is like memorizing the part of a car engine without anyone telling you what a car does. So there are three things I'll do differently. And inside each one, I'll tell you exactly what to learn and in what order. So the first thing I'll do differently before opening any code or any course is understand what a data engineer actually do and how the whole landscape fits together. Every company collects data from their website, from their sales system, from their app, from their customer support tools. Now these data are messy and is scattered across different systems in different formats and they are actually not talking to each other. Now, the data engineer job is to collect all this data and move them into one place, clean it up and make it available so that the analyst, data scientist, or business team can actually use it. Now, that's the whole job. Move data, clean data, and make the data available. Now, once you understand that, the landscape starts making sense. The place where raw data first land is actually called data lake. Think of it as a massive storage room where you dump everything as it is. No cleaning, no organizing, just raw data sitting there. Now, from data lake, you move the data into the data warehouse. The data warehouse is much more structured. It's organized, clean, and optimized for analysis. Tools like Snowflake and BigQuery are data warehouse. And this is where analysts go to run their query and build their dashboards. Then there's also something called data lakehouse, which is basically a newer approach that tries to combine the flexibility of a data lake with the structure of a data warehouse. So the journey that data takes from raw and messy to clean and structured, that's what data engineer build and manage. And that is what we call data pipeline. So spend your first week just getting this picture clear. Watch videos, read the article, draw it out on a paper. Don't touch any code yet. Just understand the landscape and I promise it all makes sense. The second thing I'll do differently is follow a clear sequence. Instead of jumping between things randomly, let me give you the sequence I'll follow today. Start with SQL. No Python, no cloud, SQL. So SQL is the language of data. Almost everything you be doing on data is with SQL. When you use dbt, you're writing SQL. When you query your Snowflake, you're writing SQL. When you model data, you're thinking in SQL. So get SQL right first, not just the basis. Then window function, CTE, aggregation, and so on. Now, once your SQL is solid, you can move into learning Python. So Python in data engineering is mostly used to automate tasks, writing pipeline scripts, and connecting to APIs. Then once you're a bit solid in Python, move into cloud platform. If I was setting today, I'll pick AWS. Now for data engineering, you want to understand S3 for storing raw files, Glue for processing data, and Redshift as a data warehouse option. Now get comfortable with how data moves through AWS before you worry about other cloud platforms. Now once you're solid with a particular cloud platform, move to dbt. dbt stands for Data Build Tool. So before dbt, if you want to transform data into something clean and usable, you're going to write an SQL script, save it somewhere, and hope that someone doesn't manually change it. Now, there was no version control, no documentation, no testing, no structure. It was all messy. Now, DPT brought software engineering discipline into data transformation. Version control, testing, documentation, modular code. Now, these are things software engineering has been doing for years. So, DBT brought it into data. And in 2026, almost every modern team uses it. If you look at any data engineering job posting right now, there is 90% of chances that you will see DBT. So learn DBT once you're comfortable with the cloud platform. Now, after you're done, learn orchestration with Airflow. Now, orchestration is just a fancy word to manage and schedule your pipeline for it to run. Airflow is the most widely used tool for this. It lets you define the order in which tasks run, handle failures, and make sure that everything happens at the right time. Now, think of Airflow as the manager of your pipeline. Now, your pipeline does the work, but Airflow makes sure that the work happens when it's supposed to. So now that's the sequence. SQL, Python, Cloud, dbt, Airflow. Each one is building on the last one. Now, the third thing I'll do differently is to stop consuming and start building. Now, there's a comfortable trap in learning data engineering. You finish one course and you feel like you need one more before you're ready to build something. And you finish that one, and there's another concept that you're not sure about. And after a few months, you've spent hours watching videos, and you still haven't built anything you can actually show someone. Now, I stayed in that trap longer than I should have. The thing is, you don't learn data engineering by watching. You learn it by breaking things, by trying to build a pipeline and having it fail without no tutorial prepared for it, by figuring out why your data loaded incorrectly, by debugging something at night and finally understanding why it happened. And this type of learning is irreplaceable, and the only way to get it is to build something real. As soon as you have a basic handle on SQL and a rough understanding of how data pipeline works, find a free data set online, move it into a data warehouse, and write some SQL to clean and transform it. Use dbt to structure your transformation, then schedule it with Airflow. That is a real data pipeline. Now, when you finish that project, put it on GitHub, write a short article about what you built and what you learned. That one project on GitHub and one article will do more for you. So let me bring all of this together. When I was studying data engineering in 2026, here's exactly what I would do. First, I'll spend the first week understanding the landscape. What is a data lake? What is a data warehouse? What is a data pipeline? What does the data engineer actually do? Get that picture clear before you touch anything else. Second, I will follow the right sequence. SQL first, Python second, then cloud, then dbt, then Airflow, one at a time, each one building on the last one instead of jumping around. Third, build something real as early as you can. Stop waiting until you feel ready. You will never feel ready. Build something anyway, put it on GitHub and write about it. Now that is it. That is the roadmap I wish I had followed. The honest truth about data engineering is that people who go faster are the ones who understood the fundamentals clearly enough that every new tool they pick up looks familiar. Start with the picture, get the sequence right, and build something real. You get there faster than you actually think. So if this video helped you, subscribe because I'm going to go deeper on each of these steps in the coming video. See you in the next one.